Today's topic, as all of you know, all of you have signed up for this, is Go with the Flow, common workflow process in Autodesk Vred professional software. Before we get started, a little bit about me. My name, as you all know, is Renu Muthu, and I'm an instructional designer. I've been using Autodesk products since 1996, I think a pretty long time, and I have been writing courseware since 1997 with my present company, which is Ascent, which is a division of Rand worldwide. I have been with the company since 2010. So the class summary. In this class, you learn about the common workflow process for Vred professional software to create high-quality, real-time renderings that realistically visualize design ideas. The key learning objectives, I think all of you must have seen those when you signed up for the class or when you downloaded the handouts, so I'll still read them for you. They are work with Scenegraph and optimize the model geometry, learn how to assign and modify materials, learn how to apply an HDR image and set it as a background environment, and learn how to work with different render setting options in OpenGL rendering method and create an image. Will be, if time permitting, I don't know how much time we'll have at the end. We'll also be touching on ray tracing, which is the other render method for Vred professional software. Now the introduction. A little bit about the format. So first of all, you will be seeing the presentation slides that's up on the screen, and after each objective is completed, I'll be demoing a little bit on the actual Vred professional software. Now, what is Autodesk Vred professional software? It's a visualization, analysis, and a presentation tool. It enables us to provide real-time graphic renderings. Now, what do you mean by real-time? So whatever you see on the screen actually is the rendered image, and you can interactively render it. Like whatever settings you're setting, at the same time they are reflected on the screen. So a little bit about comparison. If we compare it with other visualization tools, such as the 3ds Max, for example, so whatever you see on the graphic window of the 3ds Max, it actually is not the rendering. You have to set different options, and you have to imagine how the lighting effects are going to look, how the reflections are going to look, and so on and so forth, and then press the render button, and then it does all the calculations based on how complex your scene is, and also the system configuration you have based on that, and then produce the renderings. So more often than, like most of the times what happens, you always have to go back to your original graphic window and make all the changes again, because maybe the light is not showing up right, the material is not looking good, or something like that. So there are back and forth many iterations in other softwares, but here in Autodesk Vred professional software, whatever is visible on the screen is the end product. It is the renderings. So there is no need that the imagining part and the guessing game is all gone. So whatever settings you're setting here and the options, they are reflected in your graphics window, and whatever you see on the screen is the actual rendering. So what you can do with that is that you can use Autodesk Vred professional software as a design presentation. Like you can interactively do that. For example, you have to convey your design intent or show a prototype, for example, of your design. You can just have it open on your screen, make all the settings beforehand, and then interactively move around, orbit around, and show them the back of the car, for example, front wheel, maybe the steering wheel, something like that, and then that is how you can convey your design intent. Then ultimately, once you're satisfied that your renderings, render settings and everything else is working fine, your reflections, refractions, and all those, the highlights and everything else is looking great, then you can produce the images. And for those images can be used as the final proof of your design, or they can also be used as the marketing material that you can just print it in the brochures and just use it as marketing. Now, one more thing I wanted to let you know that the Autodesk Vred professional software is more geared towards the automobile industry and also to some extent industrial design industry as well. So why do I say that? Because most of the materials that are provided with the software, these materials are all geared towards the automobile industry. So we have a texture for, we can make tires look great, the treads for that texture. You can also have, like the car paint material is provided with the software. So that's why it's more geared towards the automobile industry. Now, this is the overall suggested workflow. So once, first of all, you open either a VPB file, which is the native file of Vred, or you can open more times, you open some other file from another CAD data application, because not being a modeling tool, this is not a modeling tool at all. So you have to bring in your information or the scene or the data from some other CAD data application. So, so once you bring in a CAD data, if you are bringing in a non-native VPB file, then you have to set the input options, you have to set the preferences and save it as VPB. Then you start with your normal workflow. So the next is data preparation. That is the first step of your workflow. That should be the first step most of the times. So why do we need data preparation? Because you are bringing files from other different CAD data applications, and there is a probability or a possibility that something might not be right. So we have to first organize the parts, sort all the different parts, and then consolidate them and place them in a more like you have to organize them and then sort them, reorder all the parts, and then put them together and group them together, which will work for you. For example, all the parts of the wheel or all the parts of the body, try to put them together so that later when you're working on the scene or on the objects, you know where to find them easily. Then adjust the surface normals. This is again, and because we are bringing in file from another CAD data application, there is a possibility that the normals, that is how the surfaces, the objects are rendered, the surfaces and the materials on materials on the surfaces, they render only nicely only if the normals of the surfaces are facing towards the camera, like outwards. All the normals should be outwards. And sometimes what happens that these normals, they get reversed. So we need to fix the geometry before we start applying the materials. So that's what adjust surface normal means. And then transform the geometry. Also, it might happen, or you might use it or might not use it, but sometimes you want to move your things around, or you want to copy some more information, like some object you want to copy to next position. So you can use transformation tools here, like for rotating the objects, for moving the objects, for scaling the objects. Then the next part is the materials. So here what we do is convert the materials. So for example, you are bringing in a file from another CAD data application, it comes with some kind of materials from there. So we would want, generally, we convert the materials to the Vred Truelight materials, which is because that is the main thing in Vred software. These materials that are provided with the software are best. The render quality of them is like they have been provided because the render quality is optimum with those materials, the Truelight materials that are provided with the Vred software. So it's always better to convert them, or you can create new materials and then assign them to different parts on the object. And here also we need to calculate ambient occlusion. So it is just, ambient occlusion is just, it imitates how the lights are falling on the objects and then how the shadows are created. Why we do this is because the render method, that is the default render method, is OpenGL. And OpenGL render method, it cannot create physically accurate lights, physically accurate shadows, and physically accurate reflections and refractions. Is to add realism in the normal render mode, which is the default mode OpenGL, we need to have ambient occlusion. So it creates those shadows, and in, for example, in dark crevices or around the edges and so on, and then it saves that ambient occlusion and bakes it onto the model itself. So you don't have to recalculate and recalculate it. You have to calculate it once, and then it is put with, it comes along with the objects. So that's the part here. Then the camera environment and lighting. So the camera, you can add camera views so that, for example, whenever you are having a real-time presentation of your renders, so you can save those camera views, and from one camera view you can move to another camera view, show them in a different orientation, the objects. Similarly, have an interior camera view, and so on and so forth. So you can add camera views here. You can add environments. So by default, there is already an environment that comes along with the Vred Professional software. So every object, like whenever you open even an empty scene, the environment is already there, the default environment. But you can add your own environments, as like use the HDR images and put them as your own environment. For example, you want to place a car on a road and show the trees as the background, or show the buildings as the background. So you can use your HDR images to add those environments. Then add lighting. Now, this is also optional because the environments that are, by default, the environment that is provided with the Vred software, or the images that you change by changing your or adding your own environment, the lighting, the highlights, the reflection is got from the environment itself. So the lights make no effect. Like, it is just to add, if you are adding lights, you can add them to add drama, for example. Okay, I want a spotlight on top of my car. That is by that you need those lights then. So these are additional lights. They are not the actual lights. The lights are already coming from the environment that you're using. So also sometimes you want to display the interior, you want to showcase the interior of a car, of something, and then at that time you can add lights inside the car, so that you add more, because it's dark inside, so that it's more visible and nicely visible. Then the visualization. So from the get-go itself, whenever you have any object on any scene open, it is already being visualized. But here you can set the render options, render setting options, and enhance those renderings and make them visually spectacular and stunning. So now I'll touch upon, there are two render methods that are available with the Vred software. One is OpenGL, and this is the default rendering. So whatever you see on the screen is being rendered using this OpenGL rendering method. And as I mentioned before, it does not have, it produces near photorealistic images and near photorealistic renderings, but it is not actually photorealistic because of it does not have physically accurate shadows, physically accurate reflections, and so on and so forth. But the ray traced rendering, so there's another option that is provided. You can use that, and that is the ray tracing rendering method. And this is where actually the photorealistic images and the photorealistic real renderings are produced. So now a little bit about the interface. You can see on the screen that is how a general interface looks like. And at the top, hello. Oh, sorry. So at the top is the menu bar, and menu bar has, it groups all the different commands that we'll be using, and these commands are grouped together like more logically or so, and then put in the pull-down menus. So then below it is the icons bar. So icons bar, they have little icons, and from here you can still open all the different commands. These are the commonly used, the commonly used commands that you will use more often. So that you can easily access those commands and options, things like that. So these are also available through the pull-down menu, but it's an easy and fast and quick way of looking for those commands, whatever you want to do. So that's the icons bar, number 2. Then the number 3 at the bottom of the render window is the quick access bar. So what it does is, again, it has icons, and from here we can open the different modules that are present in the Vred software. So what are the modules? They are like dialog boxes. Generally in other Autodesk programs you have dialog boxes. So these are modules, but the difference is that you can have 3, 4, 5 modules open, and you can simultaneously be working in all of those, setting your options in those modules. You don't need to exit any of the modules for those options to take effect. So what happens is it simultaneously, interactively, when you're making any changes in one of those modules, it will show up in the render window. It's reflected in the render window. So you don't actually have to close those. You can leave the frequently used modules, and you can minimize them, but they are still open there. Then one of the modules I have opened up is the Scenegraph. And I have it docked on the left side, so you can dock those modules. You can dock them on the left side, right side, bottom, or you can leave them as freestanding, just looking like dialog boxes. So then the main area is the render window. So most of the area is taken up by the render window. That's why, like in other softwares, we call it graphics window or drawing window or something like that. But here it is called as the render window because it is the rendering of the objects or the scene that is the rendering right there. So that's why it's called the render window. So then at the bottom is the status bar. It just gives you information about how much memory you're using, which render method you're using. You can also have the ICV down there. What ICV means is the initial camera view. So for example, you set this view as your initial camera view. So every time you open the file again, it will open in this orientation and this position. If you are currently working in the scene and you have orbiting around and you want to go back to your initial camera view, all you need to do is in the navigation cube up there, you have the home button. So click on that home button, it will take you back to the initial camera view. That has been saved with the file. So next is just the import options. So for example, you are bringing in files. So it can bring in, Vred can bring in huge number of different kinds of files from all different kinds of applications. So all the Autodesk files, like the drawing files, AutoCAD files, Inventor files, Revit files, and from other applications as well, CATIA, Creo, STL, FBX, you name it, and you can bring it in the data, you can bring it into Vred Professional software. So for that, if it is a non-native file that you're bringing, then the import options dialog box shows up. So if you're not bringing if you're bringing a native VPB .vpb file, then it doesn't matter. It won't, you won't get the import options dialog box. So here I have given you a few options how to set them, and it is actually whatever works for you. You can use the different settings. So for me, I just use apply materials from asset manager. I clear that because I want all the materials that are gotten from the original CAD data software And it is converted into the Vred Truelight plastic material. So all the materials are converted into the base plastic material. From there on, we can just keep on converting them to the required material. For example, maybe brushed metal, chrome, the metallic car paint, the tire, and so on and so forth. So also center in origin, put onto ground, and adjust object size. I keep them selected because it places the objects in the center of the environment. It puts it on the shadow plane, that's the ground of the environment, and adjust object size once you give it the object size, it is relative to the size. For example, you are bringing in a car, just move the slider to the car. So that it just, it's relative to whatever you see on the screen and your scene is, like your objects are. So then in the tessellation rollout up there, we just said for a good quality rendering, yep. No, yes, it does. It based on that, like because it actually does not scale it, but it is only for to show for the rendering to look really good. So, for example, you bring in it is just for the Vred to know what kind of resolution I need to set or how big my render window should be. If you tell the Vred software which one it is. It does not actually scale the data. No. Then in the tessellation rollout, for a good quality render, we set the tessellation quality to high, generally, and that gives us a good good renderings. So rest of the options, we leave them as is, because they have been already set to the optimum results for renderings. So we don't need to, these are for advanced users. If once you get into surface analysis and things like that, then we start setting all those different options. So how do you select objects when they are on the scene? So we use the mouse, but the only thing different here than other Autodesk products is that you have to keep on, you press shift on your keyboard and then you click on the object to select them. Similarly, you have the Windows option, the crossing option, using the shift. You also can select your objects using the Scenegraph. And the selection display, this is in the icons bar. You have the wireframe and the boundings. So this is only to display your selections in the render window. It is not actually like, for example, you select an object and you don't have any of those two options selected. It doesn't matter, your object is still selected and all the changes that you're making are being applied onto that object. It is only a display option. In your render window, you see them as an orange wireframe if you have a wireframe clicked on, and otherwise you have an orange bounding box around the window, around the selected object. You can have both of them on, or you can have either one of them on. It's just the visual display. Now the first objective, before I get into the demo, I'll show the demo of the interface along with the first objective that we'll be going over. So the first objective is work with Scenegraph and optimize the model geometry. So the Scenegraph, as you know, I told you it is a module that is provided along with the Vred Professional software. What the Scenegraph is, it is generally, it lists all the objects that are on the scene that are listed, that are present in the scene are listed here. And they are listed in a hierarchical fashion in a tree structure. So all the objects that are listed are called as nodes. And in front of each one of them, as you can see, is a different type of icon present. What that indicates is the type of node that is present. So this is, why is this important? Because we need to know what kind of a node we are looking at. So we can have regular group nodes, transform group, animation, all those different kinds of nodes. You can just read them later. There is this geometry node as a small blue polygon. You can see the triangular thing. That is the simplest form of the node present in the Scenegraph. And the regular group node, the first one, is the simplest form of the group node. So our intent always is to optimize the model geometry. Why do we want to do that? Is that because it will enhance your renderings. It will not affect the performance of the Vred software. So for that, we need to have to optimize the geometry. And optimizing, what optimizing means is that each regular node should have a geometry node inside of it. There should not be, the tree structure should not be deep down, like a node has another node, another node, another node, and then the geometry is there. So what that does, it affects the performance. It affects the performance of the renderings. So it is always recommended to have fewer number of nodes, optimize the geometry. Another thing on optimization is that, I'll actually go to the next one. So here, I'm saying in the Scenegraph, you can reorder nodes, sort and group objects. So here a little bit, when you bring in CAD data file into the Vred Professional software, what happens is that lots of nodes are created, and they are haphazardly placed in this tree structure. So, for example, you have to apply a material onto some, maybe the exterior of the car. You cannot find it easily. So to find your objects easily, you should reorder them, group them logically so that it's very easy to find them. Then another thing is optimize the geometry, as I was talking for the previous slide also. So what happens is that if you have those NURB nodes, as you can see, it looks like that blue curvy thing, the NURBS node or the material node or even the transform group node, animation node. So what it does is these nodes tell you that there is a lot of information along with that object that is saved in there. So it affects the renderings. It affects the performance of the renderings. So we need to optimize these. So convert all those NURB nodes into the simpler geometry nodes. Regroup them, consolidate them, and then optimize them. So what happens in the screen, if you see, there are 2 group nodes inside of the main group node, and there are 3 geometry objects. So we drag and drop those 3 geometry objects into the main group node, and then when we say the optimize, there is an optimize module. We'll be touching on it later in our demo. And if we say optimize, it just removes those 2 empty group nodes. So you don't have many nodes in there. Sometimes also, if there are 8 or 9 geometry nodes and they belong to the same object, it calculates behind the scene it calculates, and it can consolidate it into 2 geometry nodes. So optimization is really important. Then you can also create modify nodes. You can create groups. You can just move them. You can modify all those nodes. You can also isolate parts from Scenegraph. How you can do that, sometimes it's important because if you're working on complex scene and complex geometry is there, so, and overlapping geometry is there, and you, for example, want to work on an inner part of some object, so you can just take those inner parts in the, look for those inner parts in the Scenegraph, drag and drop them on the render window, and it will just isolate those parts. Then after you have completed your work on those inner parts, internal parts of the scene, then you can bring in the complete scene back on. So Then adjusting the geometry, as I mentioned before, all the normals should be facing towards the camera. And how you can see that, you need to first check the geometry. And that can be done in the vertex face normal rendering mode. And this can be opened from the visualization menu bar or by pressing F5. So here what you have to, what our intent is that it changes, in this rendering mode, vertex face normal rendering mode, all the geometry is either displayed in those 4 colors. It is either green, blue, gold, or violet. So green geometry is the correct geometry. So which shows that all the normals, the vertex normals, the face normals are facing outwards towards the camera. And that is how they should be, for the materials to show up nicely, for the lighting to reflect better. So all those things, so for that reason, it should be corrected. So if you have blue, gold, or violet, you need to correct those and make them green. So if you have somewhere the object is blue, you need to change it and make it green. So we can do that. We can correct or fix geometry using the geometry editor. It is one of another modules that is present inside of Vred Professional software. So in the geometry module, you have the flip normals area where you have those 3 buttons. And so face vertex, it repairs the blue objects and makes them green. Face surface, it repairs the gold objects and makes them green. Again, vertex, it repairs violet. So another option is present, Alt and right click. If you press Alt on your keyboard and right click on the object which is not green. So it changes sometimes it is that not the whole object is violet, or not the whole object is, one of the complete object is gold. So if you have just a few surfaces that are of a different color, but the rest of the geometry is green, and you want to change those small surfaces inside of a single geometry, then you use Alt and right click on them. So it changes it to green. So before we get into the next objective, I'll just demo a little bit about the Scenegraph, the interface, and how to optimize the model. So for example, this is the model that is opened up, and I don't see the, I don't see the, I think something is not right with the resolution of the display here. I cannot see my icons, the modules at the bottom. So I'll just try and close. Just give me a moment. I'll try and fix this. I think it's the display option that had been set with this. I'll reopen the file and then see if it opens correctly so that I can access the icons bar at the bottom. For this one, it opens up. It'll take just a minute or so to open up, and we'll start from there. Yesterday when I went to there was a speaker-ready room, and we had to go there and test our laptops and see if everything worked well, and everything was perfect there. And today morning when I come here and the IT person is not here, and everything is like not working the way it is supposed to. So that's what happens. So okay, so at least we got this. So what am I going to do is that open, so as you can see, this is the interface. These are the menu bar, and these are the pull-down menus up there. Then this is the icon bar at the top. We have the quick access bar here at the bottom. These are all the modules that we can open. Also, there are many more modules that are available with the software. All you need to do for that is right click on the icons bar or the quick access bar, and here you go. These are all the different modules that are available. And then there is the status bar at the bottom, and this is the ICV position. For example, I'm orbiting around, and now I want to see the the original view which I had saved. I go into the navigation cube up here and click on the home button, and it goes back to the ICV position. I'll open one of the modules because we have to work on Scenegraph. So here is the graph icon in the icons quick access bar. When I click it, it opens my Scenegraph right here. So Scenegraph, as I told you, it's like a tree structure and more like a hierarchical tree structure. Now this root node is always present. So root node, even if you open an empty scene, the root node is present along with all the 4 different views: perspective, front, side, and top. And also the environment node is always present because the environment comes default, even if you open if you have an empty scene right there. So this alias world in green color, it shows my objects. So I open up using this plus sign on the left, or I can also use the slider down below. It will open up the tree structure. So let me open it up, and I'll show you what I've done. For this car, I have grouped it into as an exterior and interior. That I did. Then in the exterior, I have made parts like wheels, headlights, doors, rear end, front end. So that's how we organize we should try and organize that works best for us. Whatever the intent of our rendering is, we need to organize our parts that way. So then if I open wheels, under wheels I have back. So this, if I click on it, it will immediately select the back wheel because I have grouped all the parts of the back wheel inside this back here. Now also because I am clicking on parts in the Scenegraph and they get selected. So see, so whatever I click here, I can select the objects from the Scenegraph, and the display option that we have set right now in the icons bar, I told you about the wireframe and the bounding. So the bounding is on. It shows orange here, so the orange bounding box is around the wheel right there. You can also have wireframe on. If you set wireframe, there you go. The whole back wheel gets selected. So it is just the display. These two are just the display options available. Then now I'll show you a little bit how to organize and optimize the parts. So for example, this is how all the parts came in, like skin 761, fillet something. That's how it came. It was an alias model that I had gotten into Vred software, and these are the objects that came in. And I have no clue what these mean. And for example, I have to apply some materials. I have to maybe fix some geometry. I don't know where to go and what these objects are. So I will just try and select those objects. Using the shift button, I'll select all these buttons, and there I go. Here I see this is the front wheel actually. So what I can do is I can go in here in the wheels category, right click, and then here I say create, and then I create a group here. So first of all, I'll create a group and then name this group. So a group is created, and name this as maybe front wheel. So I'll say front underscore wheel. So that I know, try to logically sort, group, reorder all the different objects inside the scene. So the front wheel is created, but I think it's created not in the wheels category. Yeah, it's under, oh no, that's fine. So now what I can do is I can take all those objects and just click and drag and drop all of them into the front wheel. So there we go. So now we know these objects belong to front wheel. So, and when I select, I don't have to actually, to select object or to work on the front wheel, I don't have to go inside and then keep on selecting different parts. All I can do is select front wheel and everything is selected. So if I have to apply material to the whole body or something like that, I can have an exterior body, just select that and apply the same material to it. Or it has to be logical, the way you want to and whatever your intent is. Now the second thing is that in this back, I'll show you a little bit how to organize and how to optimize. So these are all right. So for example, this node 5524 is down here, and this is not a simpler form of a group node. This is a transformation node. So we want to actually make into a simpler form of group node, plus it has two different other nodes. Inside of this node is one geometry, then there are two geometry here. So all we can do is just click on the three geometry pieces using the control key on the keyboard, and then drag and drop inside of this node first. Now if you select this node, you will see that it is actually the rim part. It is the rim of the back wheel, so we can just name it as rim so that we know it's rim. And then right click on it and then go to edit and open this show optimized module. This opens the optimized module right here. Now in this optimized module, just keep a watch over what happens, because this rim, this is a transformation node. We want to convert it into a simpler geometry node, not a simpler group node. And then these two group nodes are extra. They have nothing in them. It just adds more information into, and it has more number of nodes. So all we do is click on this and then select. We'll say clean up group nodes, merge the geometry nodes, and we will also use this option here, flush transformation nodes, because it is a transformation group node. I don't want it to be a transformation group node. So I'll click on that, and then here I go and say optimize. Now notice what happens. It will automatically remove the other two group nodes. This transformation group node is converted into a simpler form of a group node, and the shell are just one hierarchy is there inside of rim. Similarly, I'll open this one and show you there's a material group node inside of it. And we don't really need this information. It stores a lot of information, material information from the previous CAD data application where it was created. We don't need it here right now. So what we'll try to do is we'll go here, right click, and then first go back to the default options, choose the default options, and then use this flush material group nodes, which is already on by default. We'll use that. And also we'll say clean up the group nodes then and merge the geometry nodes. And then say optimize. See what happens? There are 4 geometry nodes, there is 1 material group node, and there is 1 extra node inside of there. So when I say optimize, it removes that material group node, converts this node into a simpler group node, and only 1 geometry consolidates all these parts as one geometry node. So this is what we need to do most of the times, organize and optimize it. I will, because we are short on time right now, I will answer, I'll take questions at the end of the session, if that is all right with you. So is it fast? Well, you say those preferences, whatever we have in there. I think right now you can find them in the help section, and I have also tried to explain some of them in my handout because I don't have that much of time that I can go over each one of them right now. But as the name specifies, that's what they do. Like, for example, merge the geometry nodes. It will, based on the geometry it finds, it will try to merge them together if they are together in the scene. Similarly, clean up group nodes. If it finds an empty node, it will clean it up and just remove it from there. Similarly, I'll show or the material, flush material group nodes. If you find a material node, use that one, and it will just convert the material node into a simpler form of a group node. And all of these, so on and so forth. So that is how you need to optimize. Now we'll go and I have to touch on actually, yeah, I'll show you, we have enough time. I'll show you a little bit about how to fix the geometry if you see the normals are not facing in the right direction. So if I just go open, so as I mentioned before, you cannot check whether the normals are correct or not. You need to go into face vertex render mode, and that can be found in this visualization pull down menu, and right now it shows realistic rendering. So instead of realistic rendering, we want to go into vertex face normal rendering. So if we click on this, yeah, I have selected the node, and then I'll go back to the realistic rendering and not select anything. So if you have to deselect, shift and right click, it deselects everything. So visualization and then vertex face normal rendering mode. So here you go. See, some objects, there are some objects which are blue in color. And we need to fix this. Everything should be green for the rendering to show nicely, for the materials to show up in the correct way. So we need to, this is just the checking part. We need to fix the geometry. So I'll quickly show you, there is one gold here as well, and the blue options. So I'll quickly show you how you can just correct a few of them. The bleeding you see in the shadow plane, it is just my graphics card, and it should actually show up as green. This is just bleeding right now here in the shadow plane. It's nothing, it's just the rendering, it's the graphic card of the laptop. So so correcting the normals can be done through the geometry module, and that geometry module can be, all the modules are listed. Some of the modules commonly used are listed here, but the geometry module is not here. So I right click here, and then I go and open the geometry module. So geometry editor is right here. That's the geometry editor module. And in the flip normals, I don't want to dock it because they're, yeah. So in the flip normals, we have face vertex, we have face and vertex, we have vertex. So these three options, based on the colors, we have to use one of those options to change it. So first select the portion. So I'll go shift and click and select this part. So it selected it. You can, it's been displayed in the render window. And then go as face and vertex. Blue can be fixed by using face and vertex, because what is in blue, both the face and the vertex normals are reversed. So when it's blue geometry, both of them are reversed. So at that time, I'll say face and vertex, and then if I shift and right click to deselect, it has converted into green. That's what we want. Similarly, choose this one and go again face and vertex, and then if you go back, so it is green. Now I had another option that I told you was Alt and right click. So in situations like this, for example, here is this M thing here, like the logo. So only those few, this is a single object. So for example, if I choose this object, select it, you will see this is one object right here. So if I keep on, for example, so only a few parts or surfaces are blue in here. So if I go and right click, I'll show you. Only this part and this part here is blue. Rest is all green, rest is correct. So I'll show you, if I select it and then I use the face vertex, what it does is it will reverse them. So this makes the whole rest of the portion blue, and this makes it green. So this is not what we want. We want everything to be green. So in this situation, you use Alt and right click. So Alt I'm pressing Alt on my keyboard and I'm right-clicking here. So see, it turned green. So individual parts of a main object can be corrected in this way. So right-click, and that's how it is done. So that was the next option, and there are other different options for gold, for violet. If you find those discrepancies in your objects, you need to correct them at this point. So we'll close the. Yeah.
Is there a way to have it, let's say you brought in data, you really need to do a quick rendering of this, there, as part of it, is there a way to have it do two-sided faces? I know it wouldn't be as efficient.
No, I don't think so. But you can, what you can do is select the complete model, and no, if you use the optimize module, I think you can do it in there and use the in the optimize module. If you just choose only the default options that were already there, and then say optimize. And also, when you bring in a model, so it is always good to right-click and optimize the main model itself. Using all those default renderers, it minimizes those things. Yes, it tries to correct all those issues at that point, but it does not clean it up completely. You need to go back into this face vertex mode and then correct it manually. You have to do that. But this takes care of a lot of things. The optimizing, when you press it on the complete model, it takes a little while if I do it right here, because it's a lot of geometry. It's trying to merge them. It's trying to fix all of those things, but it helps. Yeah. So that's about. So let's get back to our PowerPoint presentation. So the next objective that we have is learn how to assign and modify materials. So now, one more thing I just forgot to tell you. So once you are in this face vertex normal mode, how do you go back into the realistic rendering? You can just choose that visualization pull-down menu and go into realistic rendering. That is the original, that is the rendering. Or you can also press F3. F3 is for realistic rendering. So quickly you can do that. And for the face vertex normal mode, F5 is, you can just, if you don't want to go through the pull down menu, the shortcut is for F5 for that one. So learn how to assign and modify materials. So we have fixed the geometry, we have optimized the model, and now we are in the material editor. So another module, one of the most important modules that is present in the Vred software is the material editor. And here you have all the materials. So you have the material editor with different sections. So I'll quickly go over them. There's a groups and tags section which lists all the materials that are present in the scene. So these names, the material, whenever you brought in the model from another CAD data application, whatever you had named them, these are the names that will show up. But because you had selected that, cleared that option, apply the materials from the asset manager, what happens in that case is that all the materials will be basically converted into the Vred Truelight plastic material. So from here on, you need to convert all those materials to the required material you want, and then that's how, and then apply it. Or if they are already present, you need not apply them because they are already there. They have been applied in the originating software. So this group tag section, it lists all the materials that are present in the scene. The preview is again the same thing. It also lists the same as all the materials that are present in the current scene, but it also shows you the shader bar, so the shader ball, so at least you can visually see what it is. Then the third is the attributes section. When you click on one of the materials in the group tags section, the attributes show up. And this is where you can manipulate the models, change them as per your requirements. And these are best for that kind of a material. Because if you see the top rollout in here says metallic car paint material. So that material is best used, all the options that are inside of it and have been set already are the best for the metallic car paint to render. So only modifications you might need are the color changes, for example, for the material car paint, or sometimes you want to add the clear coat, sometimes things like that. So they are very specific for them. And then you can modify materials and assign materials. So there are 17 Vred Truelight materials that are provided with the software, and they are best for automobile visualization. So then you can create material. How you can create material is by going into the material groups tag section, right click, and there you have the create material. When you open that up, all the 17 will be listed, the material, the Truelight materials. Similarly, you can convert material. For example, you already have a plastic material there. So all you need to do is click on that material, right click, say convert material to Truelight material, and then choose the material you want. So right there. So you can convert materials, modify materials. In the attributes section, there are a certain number of attributes, rollouts, which are common to all the materials, no matter which material you are choosing. So these are incandescence, transparency, displacement, ray tracing, and common. In incandescence, it is self-illumination. You can set this different intensity of the self-illumination. Transparency is how opaque, how transparent. Displacement is for 2D maps to give them a height. Ray tracing are specific for only ray tracing rendering mode or ray tracing materials. And common, it has the occlusion settings, how dark you want the ambient occlusion and things like that. The rest of the rollouts, they have options which are specific to the material. So for example, this is the chrome material. It has the roughness texture and the bump texture. You can add those different textures in those rollouts. At the top, you see chrome. This is just the name. This you can modify it. You can have something. You can have rim. You can have anything up there. So, but the base material you can figure out from the first rollout. Whatever the first rollout is, that is the base material. So as I said before, there are certain common materials, and then there are these specific rollouts that are present in different, all different materials. So a few of them, I'm just, these are few important ones I'm trying to say, trying to explain here. So it is the texture channels. So this is a texture rollout is sometimes present, and this can be used to apply a texture. So for example, you want the car seats to be plaid, to be leather. So you can apply the texture here as a bitmap, a JPEG, PNG, you can get it. So you can load it, you can delete it, you can reload, you can save, and then you can modify different settings there. So this is for the texture channel. Another good thing about some of the materials like the chrome or the brushed chrome, brushed metal is use structure. So it also creates that bump effect, but it is inbuilt in the texture material itself. So you can use this used structure and then create those metallic grainy effect, bump effect in there. So you don't actually have to apply a material or a PNG, JPEG or something like that. You can use used structure. These are some of the attributes for some of the Vred Truelight materials: the chrome, the car paint, the tire material, where you can put, you can apply the load the textures for the treads, tread marks, or the sidings. So it is specifically meant for the tires. Similarly, there is glass. There are other materials as well. 17 are there. So how we can assign materials? If you create a material and you want to assign it to some part object, you can either drag it from the material editor and drop it in the render window on the object. You can drag and drop, like drag it from the material editor, pick that material and drop it in the Scenegraph, on the object in the Scenegraph. You can also copy and paste material. For example, you have already applied a material. For example, you have those chairs here. You can just pick that up, copy that material and paste it inside in the render window itself. But in that case, you have to use M key on your keyboard. And also there is a material editor shortcut menu that has been provided. You can use the shortcut menu and say apply to the selected nodes. Then the ambient occlusion, a little bit about that. As I told you before, ambient occlusion is just to create shadows and in the crevices and just to add more realism. The ambient occlusion is generally, it is used with the OpenGL rendering method because and also certain, if we choose certain illumination modes in ray tracing, there also we use ambient occlusion. So again, we have to first check if the ambient occlusion is present or if we have already calculated it. We can do that in the ambient occlusion rendering mode. We have to, like we went into the normal face vertex mode, there is another mode, rendering mode, which is the ambient occlusion rendering mode. There you can check whether the ambient occlusion was applied or not. It shows you only the dark gray and light faces, so it shows you that yes, it was applied. And then the intent is that once you have calculated the ambient occlusion, it should be really, really smooth for actually the rendering to have a good for a good rendering. So as you can see, there should be no blotchiness, no spots should not be there. That doesn't give out good renderings. So you need to correct that, and that can be corrected in the ambient occlusion module that is present with the software. So before we get into the next objective, I'll demo a little bit. So here, for example, this is a model, and we want to apply, so I'll just quickly go and open the material editor. Here in the materials icon in the quick access bar, so here I open the materials. So these are the different materials that are provided, and I have changed them. I have renamed all of them based on what they are. So you can easily find those materials. And for example, I'll show you this teak material. This came along with the main alias model when I had brought it in. So it said teak, but when you can see it here, I select it and it has actually a plastic material in there. So that is what happens when you bring in the model from another CAD data. Although the name says teak, but inside everything is converted into a plastic material. So here I need to go in here and convert it. So I go in here and say convert to Truelight material, and maybe it was a teak material. I need to use a teak map, a 2D map, a PNG, JPEG, if that was provided, and apply teak to the inner portions. So I can go and I can use the triplanar. Triplanar is specifically triplanar material. These are all the different 17 materials, the foam, plastic, triplanar, reflective plastic, so on and so forth. So the triplanar is basically meant to apply materials. If you have a leather texture, you want to apply the leather texture, or if you have to apply the teak texture here, wooden texture, something like that, you can use triplanar. So this is how you go about it. So convert and to Truelight material and triplanar, or any other material for that matter. So I'll also show you a little bit about one of the materials that we can apply and how we can create a new material. So here, this is the rim portion, for example, the inner rim portion. So see this portion here, if I show you. So this inner rim portion, what we want, maybe we can apply a brushed metal, aluminum type of a material in here. So let me go ahead and create a new material, and then we can apply it to this, the rim portion here. So I'll go now creating a new material. Till now I showed you how to convert. Now you just right click anywhere and say create material, and all the materials are here. So for this, for aluminum, I need to have brushed metal as my base material, and then I can modify it to more like look like aluminum, and we can add some structure to it. I'll show you a little bit about that. So I added a brushed metal material, and I will rename it as rim, maybe. So rim. So here, as you go in the attributes editor, this is the name up here at the top. The name up here at the top, and then this is the brushed metal material. This is the first rollout which shows that it is a brushed metal material. So in the brushed metal here, you can, all the different metal types are given. So we wanted aluminum, so we already got it. You can have silver, gold, cobalt, copper, different materials, metal materials are provided inside of this. So you can choose any of those metal materials you want. Yeah, I'll go back in here, and I'll try to show you how to apply that structure. So this has not been applied to it yet. The aluminum material, because we just created it, we didn't assign it to something. So if we have selected it, we can always go right click and then say apply to selected nodes, but we don't have anything selected right now. I cleared that option. So I can just drag and drop. So rim, and as you go, it connects that shader ball along with the cursor, and then you can keep on just going. I'm still holding my click. I'm not dropping it anywhere. So you can go and find the right place where you want to drop it. So it will just see how it changes the color if you want to drop it there. So I'll drop it to the rim and rim part and say, there you go. So now it has been assigned to the rim part. I applied the rim material to rim. Now let's go, I'll just, right now if you see, it is a plain material, and maybe we want to add that bump texture of a metal grain there and show how the grain follows the path. So in here, so let me go in here, the bump texture rollout, I'll open that, and there you can either apply a texture. If you have a grainy texture you want to apply, you can apply the texture, say use texture, or you can use the structure that is the inbuilt bump texture. So I'll use structure, and I'll try to show you how to make it effective. So as you can see already, if I zoom in, you can see there is a little bit of bump added, but it is all over the place, like it is just small dots that are visible. So, but that's not the intent. What we want is a grain, metallic grain-like thing, and which should follow a certain direction. So now if we go into brush orientation. So for brush orientation, instead of using the brush mapping, we don't want triplanar, we want a radial. We want it to be in a radial way, so we choose radial XZ here. And see, can you see how the grain material shows in a direction? So this is how you can add texture, but it still does not show in the right direction. Maybe we want it radially around the wheel to go around like this, in this direction. So all we need to do is we have to go in and find the center of the radial mapping, because it's a radial texture. So we say center and we say get center. So, but it will get the center of the selected object. So first we need to select this object, go and shift, so it will get the center of it, and then place it radially around it. So get center, and if I deselect it, here the radial, now it is in this direction. And also if you want to increase the depth, decrease the depth, you can go back into the bump texture and change the intensity. So if you go into bump intensity, see, it's deepening all those the embossed kind of a way, the texture has been added, is adding. So you can go lighter or darker, or like, I mean to say deeper or superficial, something like that. So yeah, you can keep on going. So that is use structure. Yeah, we assigned the material. Now a little bit about ambient occlusion. So that's how we can assign material. We can also, as I told you, assign material by dragging and dropping, copying and pasting. You can just choose it. If I go ICV. Okay, so we can just click on M and then pick this material up and then drop it onto the another rim and say M and right click. So it applies it there as well. So that's copy and pasting the material. Now, ambient occlusion. As you can see here, there is nothing, no shadows below the object, below the car. But you can see that from the environment, the lighting is already there. So how can we build those shadows in the OpenGL rendering method? So that is where we use ambient occlusion. So if we go in here and we check whether we have ambient occlusion or not, we don't have actually. So I'll just show you how it will show. So visualization, and you go into ambient occlusion rendering. So choose this. So nothing, there is white, because there are no dark gray areas, no shadows have been applied, neither to the shadow plane, which is the surf base, or not to the model itself. So we need to apply a little bit of ambient occlusion just to add more realism to the scene. So let's go back into the realistic rendering, and I will open the Scenegraph to select my shadow plane. So shadow plane comes with the environment. So whatever the environment is being used, the default environment is studio. That always comes in no matter what. So the studio has two parts to it. One is the dome, that's the upper part, and the shadow plane. So we want to add shadows to the shadow plane. So right now, what ambient occlusion, when we say calculate, it imitates how the light is falling. It imitates that and then guesses how the shadows would be. So that's what ambient occlusion does. It is not physically accurate. In the real world, that does not happen that way. But it is just to add realism for the renderings here. So we'll choose the shadow plane, which is just here, and I'll quickly add ambient occlusion, which can be done through the ambient occlusion module. So there are always two parts to it. One is checking, the other one is calculating. The checking can be done through the different visualization modes, which are found in the visualization. So checking for the surface normals was vertex face normal rendering. For the ambient occlusion is the ambient occlusion rendering. That's checking. But when you have to actually calculate, so when you were fixing the geometry, you had to use the geometry editor. Here, you use the ambient occlusion module. So right click and go and find the ambient occlusion, the module. So here you go. So now we generally, direct illumination, it should be set to high quality or maybe highest quality to get a good ambient occlusion. Ultra high takes a lot of time. So depending on which quality you choose here, the it takes time to calculate those ambient occlusions. So we'll leave it as medium. Actually, it should be high or highest for a good ambient occlusion, but I'm leaving it as medium because I want to show it here. So indirect illumination also, I'll leave it as medium quality. I'm not adding any more subdivisions, and I'll say calculate all. All you need to do is calculate all here. So it'll take a few seconds to just add. It has already done it because I didn't add any high quality. I didn't add any of those things. You can do them later on whenever you want, if you are actually producing a good rendering. So shift and right click. Now you notice there are a little bit of shadows down here underneath. So I can show you actually in the ambient occlusion rendering mode. And now you see, instead of being whole white, this darkness has been added. Similarly, so first when you bring in the model, the whole model should be selected, and then you have to calculate the ambient occlusion for the complete model. I'm not going to do that. It's going to take a lot of time. So two different ambient occlusions need to be calculated for a new model. One is the complete model, and the other is the shadow plane. You have to calculate for good to add realism. So that's ambient occlusion. Now let's move on to our. So let's move on to our next. So learn how to apply an HDR image and set it as a background. So it's again, so the environment is always provided. It is, by default, we get the sphere environment, hemisphere environment. So that's the shadow plane down there. And when we had said put the object put onto ground, it put the car onto the ground. And it also put it in the center of the environment. So the background, the environment, what does it give you? It gives the background image, the HDR image, so the background is there. The lighting, the highlights and reflections are also got from the environment. You can have different kinds of environments, shapes like box, and you can also have a full sphere, but this is the most generally used one. And then environment, you can just add your HDR image through the environment module, through the material editor itself. You have to choose the environment and then use the HDR image right there. You can load the HDR image and it will show you the HDR image right there. Ambient occlusion, this is how ambient occlusion. Also, another thing is that when you add a new environment, at that time, be careful that the shadow plane has been changed as well. You need to add ambient occlusion for the new shadow plane. So that's actually environment. I'll show you a little bit how to add any environment. I don't have much time. We have to go for question answers also. And the render, I'll quickly show you the renderings as well. So there is not much into renderings. It is just the render setting options that you need to change. So as I told you before, there are two rendering methods. One is the OpenGL rendering method. Another is the ray tracing rendering method. So OpenGL, it does not calculate physically accurate lightings. You need AO, ambient occlusion, to add realism. These are decent visualizations that you can have. For ray tracing, it is like stunning results you can get from ray tracing. It is physically correct lighting, reflection, refractions, shadows, everything is physically correct as in the real world, and but it's time consuming to create those ray tracings. So how can you create a little bit, then is the rendering, OpenGL rendering method is on by default always, but if you choose RT in the icons bar. The icons bar has an icon for RT. When you change it to RT, it sets the ray tracing rendering mode. So to go back into the OpenGL rendering mode, you have to clear the RT, or if you have to go into visualization, toggle ray tracing, or F3 for realistic rendering and OpenGL method. For ray tracing, F4 is the shortcut. So in the status bar, as I mentioned before, it will show you whether it's OpenGL, it will say RRGL, or it will say RRRT. So you'll know which of the rendering methods are being used. The render setting methods, usually this is the render settings module, and you can open it up. It has different tabs where you can set the different options based on. So generally, file output tab, file output tab, you can set the image size. It is for the rendering images. And also you can add anti-aliasing here. Anti-aliasing is for when you see the render options, because it's being rendered interactively. And if there are like diagonal, the image is a little slanting, at that time there are those jaggedy edges, like not smooth edges. For that you can set anti-aliasing, and anti-aliasing can be set actually by clicking the anti-alias button in the icons bar. It is also present in the icons bar, the anti-aliasing button. And then you can set different options here in the render setting module. So here you have the ray tracing tab. You also have the ray tracing tab where you can set the illumination modes for ray tracing. This is only meant for ray tracing. So there are 5 different illumination modes for ray tracing: CPU, pre-computed plus shadows, pre-computed IBL, and full global GI. Full GI is the optimum, like the ultimate result in rendering. So I'll show you. This is background is white color. This is the image size. I had put the image size as 1080, and this is the render quality I had set to production. There is also render quality that you can set in the render setting options module. You can set the render quality there. It can be low draft quality, production quality, or really high production quality. So this is OpenGL. With OpenGL, the rendering that was produced. This is, I had set the background as an HDR image. I had this New York HDR image, which I had set the background as the background, and that's, I had added a few lights here, and it's again OpenGL rendering method. So for that, this is the render. This is just a region rendering for ray tracing. As you can see, those marks on the left side of the grill, so you can see those reflections. So these are actually if you go in OpenGL, you don't, if you go on OpenGL method, you won't see those kinds of reflections and refractions. But in ray tracing, even the smallest of the reflections are present. And these are all, most of the time, using whichever mode you are using, these are physically accurate. So all the reflections around the bottom of the rim, you can see how the reflections are there, and how the highlights are being produced, how the colors change at the top, so how the reflections in the glass are there. So that's ray tracing rendering method. I couldn't demo this part for you because I think we're short on time. Do you have any questions? I know it's too much to take in one go. Yeah.
On the first, I have 2 questions. One is, when you set up to organize all the
parts,
the map.
Mm-hmm.
When it comes to cars, one thing that's very common is to organize by 3 levels.
Mm-hmm.
Sometimes you have different materials applied to the same parts, or you have different combinations of parts.
Mm-hmm.
How would you set up this?
I didn't actually get your, so car seats are...
So if you do this car, right, so
Mm-hmm.
it will be the base level, and then they have the high level of the same car, which would change some map of the model.
Okay.
How would you organize, you have the base car, the top level car?
Yes, you can do that.
How would you, can you do like triggers to switch between versions?
I think that can be done too, but that's really advanced. You can set the triggers because there are variants in there. In Vred, you have variants module, which is called the variants, where you have different, you set up different options like the camera views, even the Scenegraph is set differently there, and those variants are saved. So then once you have 3 different variants for the same car, you can always go in there. There's a variants module in there, which you can use to click on those variants and use them. There are different alternatives for the same thing, and that's pretty advanced in there, but that is another feature. Today we were tackling just the regular rendering, but yes, variants. There is a variants module in the software. You can access it through, show you. So VSets right here, so that's the module. So you can have different sets, variant sets, and save them. So when all the different settings, you have set your camera views, you have set your scene graph, you have set everything, then you can save them here in different.
Can you save different materials to the same parts?
Yes, you can do that too. That's another good thing. You can save them in variants as well, but in the material itself, material editor, you can have material switches. So you can have 3 different materials, or 2 generally for the switch to go on. So from yellow, you can go to blue. From blue, you can go to yellow. Yes, you can have that. That's material switch.
Okay, the other question I had was about, on the Pro version, you have that render layer option.
Where?
Render layer.
Render.
No, render layer option you have only on the Pro version of Vred.
Ah, okay.
Does that actually, would that render layer would be like the render layer for Maya, where you render the different parts of the image separate, like ambient occlusion, what they call beauty layer, and reflections. Is that the same output as Vred does?
Yes, that is the same output. Those render layers, that is the same output as you had in Maya, yeah.
Okay.
Yeah. So, so I think as much as I could in the 90 minutes time, it's so vast, it's so huge. I mean to say it needs days of practice and things like that, and you need to work on Vred to get to know. It's just a tip of the iceberg that I told you today. Vred it's the details and the depths are so much, but it is a fantastic software for visualization, for presentation, and I hope you enjoyed the session. Thank you.